All right, let's talk about where AI is really going in the next 2 or 3 years. And I'll give you a hint. It's got nothing to do with making chatbots a little bit better at writing emails. We're on the verge of a fundamental, almost hidden shift in what AI is even for.
So if you think this whole AI race is just about who can build the smartest personal assistant, you're really only seeing the public-facing tip of the iceberg. The real story, the one that's going to define the rest of this decade, is happening almost completely out of sight.
Okay, this slide right here gets to the absolute heart of it. We're moving out of what you could call the generative era, where AI was basically a super-powered search engine, a tool for answering our questions. We're now entering the agentic era. And here, the focus isn't on answering questions, it's on taking action. The value shifts from just retrieving knowledge to executing tasks completely on its own. So let's go below the surface. Because to really get what's happening, you have to understand the two hidden crises that are forcing this massive change, problems that are threatening to bring our current AI progress to a screeching halt. First up, the data crisis. You see, the very fuel that powered this whole AI boom, high-quality human-generated text and images, it's running out. The entire industry is about to slam into a massive data wall. And this isn't some far-off theoretical problem. We have a deadline. Most serious projections show that by 2026, just a couple of years from now, we will have used up literally all of the high-quality human text on the public internet for training. The well is about to run dry. So what happens then? Well, what happens is something that researchers are calling model collapse. And honestly, the best analogy for it is mad cow disease for AIs. It's this degenerative feedback loop that kicks in when you start training new models on the synthetic AI-generated content from the old models. The AI starts eating its own tail, so to speak.
And you can see the decay pretty clearly here. In phase 0, when it's fed 100% human data, the AI is creative, it's got high variance. But as you start mixing in more and more synthetic data, the outputs just get, beige. They lose all their creativity. And by the time you get to phase 3, when it's just learning from its own recycled garbage, the model completely collapses. It starts spitting out total gibberish because it's literally forgotten what human reality even looks like. The second crisis isn't about data, it's about physics, pure and simple. The silicon chips we're using are hitting a thermodynamic dead end. The amount of energy it would take to train the next, more powerful generation of models is insane. We're talking about the output of entire countries. It's just not sustainable. And this has kicked off a kind of secret hardware rebellion, a race to invent post-silicon computers. So one of the wild ideas is thermodynamic computing. See, our current chips spend a ton of energy trying to fight things like heat and random noise. These new processors do the exact opposite. They actually use that chaos and randomness as a computational tool. It's like, instead of building a dam to stop a river, you use the river's natural flow to power a mill. You let physics do the heavy lifting for you. It's incredibly efficient. And then things get really, really weird with organoid intelligence, or as some call it, wetware. And it is exactly what it sounds like. We're talking about hybrid computers that literally integrate living human neurons with traditional silicon. And why would you do this? Because your brain, right now, is running on about 20 watts of power. It is the most efficient computer known to exist. And labs are already getting these little mini brains to learn tasks way faster and with far less energy than our best silicon chips. And a third path is neuromorphic computing. These are chips designed to mimic the brain's event-based structure. So instead of being on and burning power all the time, they only fire up, they only spike when new information actually arrives. This is an absolute game changer for autonomous things like drones or remote sensors that need to run for ages on a tiny battery. And this chart really just says it all. The leap in energy efficiency we're talking about here, from our current silicon to these new types of hardware, it's not just a small improvement, it's a total revolution. We're talking orders of magnitude more efficient. This hardware rebellion isn't just a cool science project, it's an absolute necessity. So you've got these two massive crises, right? The end of human data and the physical limits of silicon. And they're forcing a pivot. Armed with this new, incredibly efficient hardware, AI doesn't have to live in a giant data center anymore. It can finally leave the screen. It can become an autonomous actor in the real world. And this opens up a whole new world of dangers, like agentic malware. Think about it. Traditional malware is basically a dumb puppet.
It needs a human hacker pulling the strings. This new stuff, it's the puppeteer. It has its own reasoning model baked in, which means it can get inside a network and just figure things out for itself without ever having to call home to its creator. So look at how this works. First, it finds a way in. Then, it starts reading your internal documents to map out the network. It identifies the crown jewels and figures out what defenses you have. Then, and this is the crazy part, it writes its own custom code on the fly to bypass your specific security. And then, it attacks. All of this happens completely on its own, which makes it nearly impossible to spot with our current methods.
And the threat isn't just about computers. In the defense world, they're developing what's called cognitive warfare. And look, this is so far beyond fake news or propaganda. This is about using AI to create detailed models of the human terrain, our beliefs, our biases, how we make decisions, and then using that model to industrially hack our cognition to change how we think on a massive national scale.
So, where is all of this taking us? These hidden forces, the data crisis, the hardware rebellion, and this huge agentic shift, they're all converging. And they're pushing us toward a very strange, very fractured new kind of world. You know, we're basically facing a choice between two different internets. On one side, you've got the dead internet. This is the public internet, which is already becoming this bizarre hall of mirrors where bots generate content for other bots to engage with. And on the other side, you'll have these private, gated human enclaves, places where you'll need biometric proof that you're actually a person just to log in, and where human-made art or writing becomes a rare, expensive luxury good. And that really brings us to the final, and maybe the most chilling thought in all of this. For years, the big safety idea in AI has been to keep a human in the loop for control. But as these new agentic systems get faster, smarter, and more independent, that human isn't a safeguard anymore. We're becoming a bottleneck. The system works better without us. And the ultimate secret of AI's near future might just be that the loop is being closed, whether we give our permission or not.